graphical representation of linear motion. Now, in the previous day we have studied when a body moves along a straight line path, we call it rectilinear motion. That is, only one dimension will change. Then we did the difference between distance and displacement. Distance was the actual length of path covered, and displacement is the shortest distance between the initial and the final position. Distance was a scalar quantity and displacement was a vector quantity. Then we went on to speed. Speed was distance by time. Speed was of four types: uniform speed, non-uniform speed, average speed, which was total distance by total time, and I told you instantaneous speed. This is when the speed changes every instant, and that can be done with the help of calculus. One important point we have discussed, that is scalar into scalar gives us scalar, scalar by scalar is scalar, vector into scalar is vector, vector into vector may be a scalar, may be a vector, vector by scalar is a vector. Now, velocity was displacement by time. Displacement is a vector quantity, time is a scalar quantity. So, vector by scalar was a vector quantity. So, in velocity we have to consider two things: magnitude as well as direction. Like speed, in velocity we have to discuss what is uniform velocity, non-uniform velocity, average velocity, and instantaneous velocity. What was acceleration? Acceleration was change in velocity by time. Change in velocity is a vector quantity, time is a scalar quantity, so acceleration comes out to be a vector quantity. Now, this chapter, what we are going to discuss today is graphical representation of linear motion. Now, in graphical representation, of linear motion, we have to study three types of graph. Number one, we have to study displacement time graph. Velocity time graph. acceleration time graph. With the help of graph, we are going to analyze linear motion. Now today we are going to discuss only the first type of graph, which is displacement time graph. Today we are going to discuss displacement time graph. Now, with the help of displacement time graph, we have to analyze what the graph wants to say. Now, first type of graph, say case 1. I have a graph like this. On the y-axis, I am plotting displacement in meters. In the x-axis, I am plotting time in seconds. Now say, we have a graph like this, which is parallel to the x-axis. Say at, say this is 0, 10, 20, 30, say this is 25. At 1 second, my displacement is 25. At 2 seconds, my displacement is 25. At 3 seconds, my displacement is 25. At 4 seconds, my displacement is 25. At 5 seconds, my displacement is 25, and so on. So, this graph tells us that with time, displacement is not changing. Now, what does this mean? Say, this is particle A. Particle A starts from here. It moves 5 meters. It comes over here. This is my displacement. This is 25 meters. This displacement is not changing. That means particle A is not moving. So when you say that with time, displacement is not changing. At 1 second it is 25, at 2 seconds it is 25, at 3 seconds it is 25, at 4 seconds it is 25. That means the particle is not moving at all. So this type of graph tells us that the body is at rest. It is stationary. It is not moving. So it tells us the body is at rest. And when it is at rest, what can we say? We can say velocity of the body is 0. So this type of graph tells us that the velocity of the body is 0. Now, in a graph, children, say I have a graph like this. Say this is a graph. This angle, let me call it as theta. Now if I complete the triangle and draw a perpendicular over here, this is 90 degree. Opposite to the angle, this side is called perpendicular. This is called base. And this is called hypotenuse. Once again, P is my perpendicular. It is opposite to the angle. B is my base. H is my hypotenuse. Now, in this graph, perpendicular by base is called slope of the graph. The graph is AB. It is called slope of the graph AB. In any graph, if this angle is theta, let me tell you once again, say if this angle is theta, opposite to the theta is my perpendicular, this is my base, this is my hypotenuse. Perpendicular by base is called, that means this side divided by this side is called slope of the graph. In mathematics, children, you will find this term known as tan theta, tangent theta, tan theta. But we will denote this as slope of the graph. Now in this figure, this line is not making any angle. Here theta is 0. It is parallel to the x-axis. Say you have a graph like this. It is parallel to the x-axis. So it is not making any angle with the x-axis. So these type of graph we can take theta as 0 degree. There is no slope. So here slope of the graph is 0. And as slope of the graph is 0, velocity is 0, so we can conclude that from here slope gives us velocity. A very, very important point. Slope of displacement time graph gives us velocity. Very, very important. Now, why is it so, children? Why is it so? Say this is displacement and this is time. And you have a graph like this. Say you have a graph like this. So slope is what? Perpendicular divided by base. Now what is perpendicular? This is actually displacement. This is actually displacement. And what is base? Base is actually time. So slope is actually displacement by time. Slope is perpendicular by base. Now perpendicular is displacement. And base is time. Now what is displacement by time? See here, perpendicular is displacement. This is perpendicular. It is actually displacement. X-axis, the base is time. Displacement by time. This part is velocity. So remember, children, this is very, very important. Slope of displacement time graph gives us velocity. In this graph, slope is also 0, velocity is also 0. Next, we move to the next type of graph. Say, case 2. We have a graph like this. This x-axis is displacement, it is in meters. Time is in seconds. Say you have a graph like this. Say 1 second, displacement is 10, two seconds, displacement is 20, three seconds, displacement is 30, four seconds, displacement is 40, and so on. This is my graph AB. So how can you visualize the case? Particle A is here. After 1 second, it comes over here. This distance is 10. In 2 seconds, it has covered another 10 meter. This is another second. So total is 2 seconds. Another 1 second, it moves 10 meter. That means the particle is moving. This is done in 1 second. So this type of graph tells us, point number 1, the particle is moving and it has a velocity. Now, What is this velocity? First we can say, number one, the displacement is increasing with time. Looking at the graph, we can say that the displacement is increasing with time. Next, I told you slope gives us velocity. Slope of the graph will give us velocity. Now, what is slope? Slope is perpendicular by base. Now, which one is perpendicular and which one is base? So, this side is perpendicular. Perpendicular is 40 and this is base. Base is 4. So, perpendicular is 40, base is 4. So, we can say the velocity is 10 meter per second. The body has a velocity of 10 meter per second. Now, when displacement is increasing with time, we say velocity of the body is positive. We say velocity of the body is positive. So, 3 important points. Displacement is increasing with time. Slope of the graph gives us velocity which is perpendicular by base. I told you in a graph, if this is the graph, then this is perpendicular, this is base, this is hypotenuse. Perpendicular divided by base is actually displacement by time, which will give us velocity. And when displacement is increasing with time, we say velocity of the body is positive. Now, a child thinks this in this way, children. I find out perpendicular as 40, base as 4. But someone wants to take a smaller triangle. Takes this one, 10, this triangle, small triangle, 10 and this base as 1. Then also the answer will come the same. For a straight line, slope does not change. So in this case it is 10 by 1, which is 10 meter per second. You can take a small triangle, you can take a big triangle, doesn't matter. Or say someone else tells me, Miss, I am going to take this triangle. I am going to take this triangle and find the slope. So this is 30, this is 20. So this part is 30 minus 20, 10. It is 30 minus 20, 10. This is 10. And this is 2, this is 3. So this is 3 minus 2, 1. This is 3, this is 2. So 3 minus 2 is 1. So someone takes a small triangle and tells slope is perpendicular by base. Answer will come the same. For a straight line, the slope does not change. Now we move to case 3. Case 3. Say, you have a graph like this. This is displacement in meters. This is time in seconds. And you have a graph like this. 0 seconds say displacement is 50. Say 1 second. Displacement is 40. Two seconds displacement is 30. 3 seconds displacement is 20. 4 seconds, this is 10. 4 seconds, it is 10, and so on. Now, here if you visualize, this is particle A. At 0 seconds, the displacement of particle A was 50 meters. Particle A was here. At 1 second, its displacement is 40. At 1 second, its displacement is 40. That means particle A is coming back. It is somewhere here. Now the displacement is 40. This is at t equal to 0, it is here. T equal to 1, it is here. At t equal to 2 seconds, its displacement is 30. That means it has further come over here. This displacement is 30. At t equal to 2 seconds. So it is further coming back. So here, what are the conclusions we can say? Number 1. Displacement is decreasing with time. That is, body is coming back to the starting point. And when the body comes back to the starting point, children, point number 2, when this happens, we say velocity of the body is negative. Velocity of the body is negative. When the body is coming back to the starting point, we say velocity of the body is negative. When the body goes away from the starting point, it is positive. Say this is the starting point. So when a body moves in this direction away from the starting point, velocity is positive. Plus VE means positive. And when it comes back, velocity is negative. Just a minute, children. Velocity is negative. Coming back means velocity is negative. Now what is the velocity? What is the velocity? As usual, velocity is perpendicular by base. This is my angle theta now. Perpendicular is the opposite side. So this is perpendicular. This is base. Perpendicular by base is slope. This side is hypotenuse. So what is my velocity now? Velocity is perpendicular by base. It is perpendicular by base. So it is, say this is 5 seconds. Perpendicular is 50. Base is 5. So velocity is minus 10 meter per second. Body is coming back means velocity is negative. Now someone can tell me, Miss, I am not going to take the bigger triangle. I am going to take a smaller triangle. Fine, no problem. Let us take this triangle, children. Any triangle, any triangle. Let me take this triangle. This triangle. Then this perpendicular is 30. And this is my base. So this is 1 second, 1 second, 1 second. So total is 3. So for this triangle, my slope is perpendicular by base. Perpendicular is 30. Base is 3. So this is 10. This is 10. It will come the same, children. Or if someone tells me, Miss, I am going to take a small triangle. I am going to do with the small triangle. No problem. No problem at all. Say this is 10. 40 minus 30, 10. And this base is 1. Because it is 2 minus 1, 1. So this slope is 10 by 1. 10. Slope of a straight line will not change. So this type of graph in case 3, we say displacement is decreasing with time. Because at 0 second my displacement was 50, 1 second it is 40, 2 second it is 30. So it is decreasing with time. It tells us body is coming back to the starting point, velocity is negative, and slope as usual gives us the velocity. Now if the graph is not a straight line, what do we do? Case 4. If the graph is not a straight line, what do we do? This is displacement in meters. This is time in seconds. Say you have a graph like this. Strange, how do we do? Here children, you can see with time displacement is increasing. Isn't it? With time, say this is 1 second, displacement is 10. But it is not increasing uniformly. In 2 seconds, say it is 30. Then it is changing in haphazardly. In the next 1 second, say it is 50. So here displacement is increasing with time, definitely. So velocity is positive. Body is moving away from the starting point. But what is the problem here? Like in the previous case, in this case children, velocity was not changing, it was 10. So point number 4 we could have told that body is moving with uniform velocity. Body is moving with uniform means same velocity, because wherever you find it is 10. In the next case also we could have told that velocity is same. So body is moving with uniform velocity. It is same. It is not changing. But in this case, every point slope is changing. Every point slope is changing. I am rubbing this just to make my, because if I draw tangents from here, things will become very untidy. Now you see, at this point, if anyone wants to find the slope, you have to draw a tangent, children. Tangent, you have to draw a tangent over here. And you have to get the slope. Tangent can be of any length. This angle is theta 1, perpendicular by base. Now I want to find the slope at this point, B. I have to draw a tangent over here. This angle is theta 2. The angle is changing. It is increasing. Perpendicular by base. Someone wants to find the velocity at this point, C. So tangent over there. This angle is theta 3, perpendicular by base. So you see, as you go up, what is happening, children? The perpendicular is increasing. The angle is increasing. The perpendicular is increasing. The base is decreasing. The base is decreasing. So what happens? The slope of the graph. Slope is what? Perpendicular by base. The slope is increasing. Perpendicular is increasing. You can see in the figure. The angle is increasing. Theta 3 is greater than theta 2, is greater than theta 1. The angle is increasing. Slope is increasing. Now what does the slope give? Slope gives us velocity. So slope is increasing. And slope gives us velocity. So from here we can say that velocity of the body is increasing. Velocity of the body is increasing. And when velocity of the body is increasing, what can you say? That the body is accelerating. There is an acceleration. So if you have a graph like this, you can say displacement is increasing with time, velocity is positive, slope is increasing, because you can see that the angle is increasing. This angle is least. From here you can see theta 3 greater than theta 2 greater than theta 1. Angle is increasing. So as angle increases, the perpendicular is increasing. Slope is increasing. Slope gives us velocity. Velocity is increasing. And there is an acceleration. Now in this type of graph, you will not be asked to do any sum, because this can only be done with the help of calculus. You will be doing this type of sums in class 11. But you can be asked questions from the graph. They can ask you, what does the graph tell us? Now if they tell you what does the graph tell us, you have to tell that velocity of the body is increasing. There is an acceleration. Velocity is positive as displacement is increasing with time. So all the 4 points you have to summarize and say, from this graph we see displacement is increasing with time. So velocity is positive. And as slope is increasing, velocity is increasing. And as velocity is increasing, we can say this is accelerated motion. This is accelerated motion. Now, we move to the next type of graph. The previous one was case 4. We move to case 5. Say you have a graph This is displacement in meters. This is time in seconds. Say you have a graph like this. From the graph we see that displacement is increasing with time. If displacement is increasing with time, velocity is positive. Next, if we want to find the velocity at this point, we are going to draw a tangent. This angle is θ1. Perpendicular by base is my slope, which will give my velocity. If I want to find the velocity at this point, I am going to draw a tangent. This angle is decreasing, θ2. Perpendicular is decreasing. Base is increasing. Say I want to find the velocity at this point, C. I draw a tangent. This angle is θ3. See, perpendicular is going on decreasing. So in this graph you see θ3 is less than θ2, is less than θ1. The slope is decreasing. What is slope? Slope is perpendicular by base. From the figure you see perpendicular is decreasing. The numerator is decreasing. The base is increasing. So the slope is actually decreasing. The angle is decreasing, the slope of the graph is decreasing. Slope gives us velocity. So it tells us that velocity is decreasing. So when velocity is decreasing, we can say there is retardation. There is retardation. There is retardation. What is retardation? Retardation is actually negative acceleration. It is actually negative acceleration. So when you are given a graph like this, you can see displacement is increasing with time, velocity is positive. This is actually non-uniform velocity. This is actually non-uniform velocity. Because now velocity is decreasing. So this type of graph tells us velocity is decreasing as the slope is decreasing. As the slope is decreasing, slope is perpendicular by base, the perpendicular decreases, slope decreases, velocity is decreasing, so there is retardation. Now if you are given a graph like this, say case 6. say this type of graphs you won't be asked to do sums. Okay. Now say you have a graph like this. So it is clear from here that displacement is decreasing with time. As time is increasing, displacement is decreasing. So when that means body is coming back to the starting point. So we call it velocity is negative. Because with time displacement is decreasing, body is coming back to the starting point. Now I want to find the velocity. So here I draw a tangent. This is my angle θ1. I want to find the velocity at this point. I draw a tangent θ2. Here I want the velocity. I draw a tangent. You can see that the angle is decreasing. Slope is decreasing. The angle is decreasing means slope is decreasing. And what does the slope gives us? Velocity. So we can see here velocity is decreasing. And when velocity is decreasing, there is retardation. So this type of graph is actually showing retardation. Here you will not be asked to do sums. These are non-uniform velocity examples. Because the velocity is changing. But you will be asked to explain the graph. So you have to say displacement is decreasing with time. Body is coming back to the starting point. Velocity is negative. Slope is decreasing. So velocity is decreasing and hence there is retardation. Or if you get a question like graph like this, say case 7, I give you a graph like this. Time in seconds. A graph goes like this. Like this. So from this graph it is telling that as time is increasing, displacement is decreasing. So number 1, displacement is decreasing with time. Displacement is decreasing with time. So when displacement is decreasing with time, we can say velocity is negative. Displacement is decreasing with time. So we say velocity is negative. Now if you want to find the velocity at any point, draw a tangent. This angle is theta 1. Draw tangent over here. You see the angle is increasing. At this point, if you draw a tangent, you see the angles are increasing with time. So slope is increasing. And slope of the graph is increasing. Slope gives us velocity. So you can say, in this type of graph, velocity is increasing. And if velocity is increasing, when velocity increases, we say there is an acceleration. As the slope is increasing, we can say there is an acceleration. Now, one important point to note over here, children. The displacement time graph can never be a graph. See, this is displacement. This is displacement, this is time. You can never have a graph like this. You can never have a graph like this. You can never have a graph like this. Displacement time graph can never be a graph. Displacement time graph can never be a graph parallel to the y-axis. Displacement time graph can never be displacement time graph can never be a straight line. Can never be a straight line parallel to the displacement axis. Now why? The question is why? Why it cannot be? See, at a particular time, say the displacement is 10. In the same time, the displacement is 20. In the same time, the displacement is 30. What nonsense is this? It's not possible. This type of graph is not possible. So if someone tells you, that person is fooling you. If someone tells you that you have a graph like this, it is not possible, children. This type of graph is not possible, because at one particular time, displacement is changing with time. Time is not changing. Time is not changing, but displacement is changing. How is it possible? It is not possible. Because in this type of graph tells us that the distance covered by the body in a certain direction increases without any increasing in time. Displacement is increasing. Without any increase in time. This is wrong. This type of graph is not possible. This type of graph tells us that a body is having infinite velocity. Velocity is infinite, which is not possible. So this type of graph, children, is not possible. This is absurd. So this type of graph is wrong. This type of graph is wrong. So from the beginning, if we go through, just a revision of the graphs. Today we are studying displacement time graph. This type of graph tells us displacement is not changing with time. So if displacement is not changing with time, slope is 0, velocity is 0, body is stationary. Next, this type of graph, case 2, it's a case of uniform velocity. It tells us that displacement is increasing with time, slope is constant, velocity is 10 meters per second here, velocity is positive, and body is moving with uniform velocity. This type of graph tells us displacement is decreasing with time, body is coming back to the starting point, and when body is coming back to the starting point, velocity is negative. When body goes away from the starting point, velocity is positive. Towards the starting point, it is negative. This is also a case of uniform velocity. Uniform means constant. Case 4, this type of graph, displacement is increasing with time, so velocity is positive. As you can see from the graph, the angle is increasing. Theta 3 is greater than theta 2 and theta 2 is greater than theta 1. The angle is increasing, and so you can say the slope is increasing. Slope is increasing. And what does the slope gives us? The slope gives us velocity. The slope gives us, just a minute children. Yes. So here the angle is increasing, slope is increasing, velocity is increasing, so there is acceleration. This type of graph tells us velocity is increasing with time, so velocity is positive. You can see that the angle is decreasing, slope is decreasing, the base is increasing, the perpendicular is decreasing. So numerator is decreasing, slope is decreasing, velocity is decreasing, so there is retardation. Case 6 was a case of non-uniform velocity again. Displacement was decreasing with time, so velocity was negative. Slope is decreasing, velocity is decreasing, So there is retardation. Case 7 was displacement, again decreasing with time. Velocity is negative. Slope is increasing. You can see the angle is increasing. Velocity is increasing. And increasing velocity is acceleration. And a very, very important point to note, displacement time graph can never be a straight line parallel to the displacement axis, because it tells us displacement is increasing without an increase in time. Velocity is infinite. This is not possible.